In this lesson, we're going to start looking at ways to organize data so that it's easier to interpret. And both of the ways we're going to look at today not only put things in order, but sometimes they can require you to kind of focus in on the frequency in which things happen so that you can use that information to help you make an analysis. So first, we're going to start with a stem and leaf plot. And it's a data display based on their digits. Each value is separated into a stem, which is the leading digit or digits, and the leaf, which is always the last digit. So here on example 1, you'll see that everything is a 2-digit number. So our stem should just have one number, our leaf should have one number. When you create a stem and leaf, and we're going to create an ordered stem and leaf, meaning we're going to start with the smallest number and work our way out as we draw each part of our stem. So I'm going to put my stem here on the left side. And I'm going to analyze my data for the smallest numbers. I believe that is the 3. Now, since 3 is a 1-digit number, that means its tens digit is 0. So I'm going to go ahead and highlight all of those values. They're going to be in the same row on my stem and leaf. So we have an 8, an 8, a 7, a 7, a 4, and a 3. So the first leading digit for that row is technically a 0. Then on the leaf side, we write the values in our data that have 0 as their tens digit. And I'm going to go smallest to greatest. So that would be a 3, then a 4, then 2 7s, and 2 8s. And that is the first row of my stem and leaf plot. And there's no need to put commas in between these numbers on the right-hand side, because the leaf is only 1 digit, so that we know that each one of those represents a different data value. All right, so let's look at the next part of our stem. So those are numbers where the leading digit is a 1, or a tens digit in this particular case. So I'm going to highlight those. So we have 14, 19, 18, 14, 12, and 19. Sometimes it's nice to highlight and or cross them out as you go just to make sure you didn't miss a data value. Again, we're going to put them in order. So that leaf portion starts with a 2, then a 4, then a 4, then an 8, a 9, and a 9. All right, next one. So next, we're going to do a stem where the tens digit is a 2. So let me go highlight those. We've got this 25, 23, 21. So our leaf side should go 1, 3, 5. All right, now I move on to the 3s. As a heads up, if ever there aren't, you'll always use everything between. So let's say there weren't any numbers in the 30s, but then there were numbers in the 40s. We would still put the 3 here. So just as a heads up, in case your data skips a value, you don't skip any numbers in your stem. You go from the smallest leading digit to the largest, and then you just don't put anything to the right if that particular digit doesn't have any items in that data set. However, that is not the case for this problem. So if we're looking for things that have a leading digit with a 3, so that's the tens digit again, that would be 37, 39, 32, So again, I'm writing it in order. So 2, 7, and 9. And the order piece isn't always a necessity. I'm doing it more so that in the future, if ever you were using your stem and leaf to find the median, then that piece would already be done for you. Oops. All right, last but not least, the 4 as our tens digit should get us all the way to the end. And I believe there's a 41 and a 42. Now, it wouldn't be a bad idea to maybe to count how many items you have on the leaf side just to make sure you didn't forget a value. But the very ending piece of this is to write a key. So if someone didn't know what this data value was, they would use the key to know, okay, so if I see 0, 3, I know that that means 3. So we're going to write a key to the side, and don't forget these on your homework. You're going to write it as it appears. So if we just did 3, it would look like this. And then you would state what that value actually equals. So just make sure you use a value from the table so that you have it as a reference point. Now, why create a stem and leaf plot? So these numbers, if you read back to the examples background of this data, is the number of home runs hit by the 20 baseball players with the best single season batting averages in Major League Baseball since 1900. So you could make inferences where it says like, hey, if you have home runs in the 40s, is that rare? And you could tell here, yes, because it seems to be that there are fewer of those. If you said all of these top players with the best single season batting averages, where do most of them fall? You would say somewhere between 0 and 20, because that's where the majority of these items fall with these numbers that are listed here at the beginning. So the beauty of organizing something, especially in order, is it allows you to analyze the data. You're going to see some like this on your Khan Academy, and it might say like how many of these players had 14 home runs, and you would go through and be like, all right, so this 14 means it's a 1 and there's 2 of them, and that's how you're going to analyze the tables or the stem and leaf plots that you see on Khan. All right, secondly, here we have the ages of the U.S. men's and U.S. women's 2004 Olympic gymnast teams, and we call this a double stem and leaf. So this stem here, it is referring to both sides. So on the right side, it's easy to read because it's kind of still in the order it needs to be. But notice on the left side, the 2 is in the middle and the 1 is the leaf, which still represents a 21. So reading the left side can kind of be a little tricky depending. Just be aware. It's why the key is nice so that you still understand, like, all right, so if there's a number there, how do I read it? We would say the 2 is your leading digit, the 1 is your leaf, or sorry, yeah, your leaf. Now, what is the main purpose of making a double stem and leaf? It's mainly for the purposes of comparing 2 sets of data. So maybe I put first hour's test scores next to fifth hour's test scores, and then we compare, and then we can make a lot of inferences about where people land, where our mean, median, and mode might be. And we can make those quickly because the data is organized into these nice lines. All right, so one of the things you can look at here, I'm just going to give you some examples that previous years have come up with. One thing you might notice is that the women are younger. Or you can say the men are older. Same thing. Another observation you might have is that no one's over 30. Another observation is that the youngest one is 16, which I believe might be the age you have to be able to compete in the Olympics. I'm not sure if it's any event, but for gymnastics. So it's really easy to see these quick observations when things are organized in this fashion. So that's your take on stem and leaf, which leads us to frequency distributions and histograms, which are actually kind of very, in a cool way, I'm going to kind of do this real quick, semi-related to a stem and leaf. It's not really, But one of the cool things, I'm going to turn this on its side. One of the cool things about a stem and leaf plot is it organizes it into intervals. So everything that fell into this piece of the stem is from 0 to 9. Then this stem is from 10 to 19. Then this stem is from 20 to 29 and so on. So in other words, we're organizing the data into what we like to call intervals. And then what we can do is create a bar graph based on how big these frequencies are, and we can tell how many times something occurs in a given interval. So it's almost like a stem and leaf can kind of directly relate to our histogram. So first off, to create a histogram, which is just a bar graph, we need to know the frequency in which things happen in given intervals. So an interval is the number the frequency of an interval, is the number of data values in that interval. One way that we break up grades is typically A, B, C, D, E. That would be an interval. So how many A's, how many B's, how many C's? Same thing, frequency, how many people fall in each range. All right, once we have calculated our frequencies, we're going to create a bar graph. So a histogram is a bar graph. It displays data from a frequency table. Which is just a way for us to organize where people fall or where data falls. Each bar represents an interval. And the bar's length indicates the frequency. One of the biggest pieces about this bar graph is that there is no space between the bars. So when you create a histogram, each bar, the only reason there would be a space is if one of the intervals doesn't have any values in it. Other than that, the bars should be right up next to each other. All right, so here's how we make a frequency table. The following data is the price in dollars of sandwiches at restaurants. And we would like to make a histogram that represents where these are at. As a heads up, and I've given this to you on Canvas, I've told you what you should use as your starting interval, mainly because for the purposes of grading, we want to make sure that all of our frequencies are the same. And on a test or a quiz, I would do that as well. I would tell you, all right, here's what I want like your frequency to be, your first frequency, or your first interval. Sorry, I'm an interval. Here's what your first interval should be so that everyone matches. All right, so what we're going to do is first, we're going to write out our intervals. So our first interval on this one is going to be from $4, because we want to make sure we include the smallest amount, and we're going to go at 50-cent intervals roughly, so $4.49. So $4, you can see this is all in order. So $4 is our least, so we don't need to go smaller than that. You can start with where the smallest is at. So this represents our intervals. So before we start tallying, I'm just going to go ahead and write all my intervals in. So if my first interval ends at 449, that means my second interval starts at 450 and goes to 499. It's really important that your intervals are of the same length. So if you subtract the bigger one by the smaller number, they should give you the same number every time. The next one should begin at $5 and go to $5.49. Then it should be at $5.50 and go to $5.99. And I believe that should be enough to include our most expensive sandwich. All right, so then you can just tally it up. So the beauty of this one is they're kind of in order, so the tally might be kind of a moot point. But once we have a tally, then we can determine the actual frequency in each. So this is kind of the general setup for a frequency table. starting with our intervals, we're going to tally it up. So I believe these first, these first 3 sandwiches, oh, I guess they're not all quite in order, and this one here, they all land in this first frequency. So if I was like $4 here, $4 here, $4.25 is here, and then we had another $4.25. So there are 4 sandwiches that land in that particular interval. All right, then so that takes care of these 4. 1, 2, 3, 4. Then $4.50 and $4.75 land here, followed by $5.95, which is in here. $5.50 also in here. Another $5.50 and another $5.75. Get a color code here just so that we can see this a little clearer. All right, so our first interval had 4 sandwiches, the second interval had 2, our third interval doesn't have any, and our final interval has 4. So there's our frequency table. All right, so here's how it converts over into a bar graph. So along the bottom is where we're going to put our intervals. And you can start right up against the left edge. So we're like, all right, so this edge is at $4 and it goes to $4.49, meaning that our next interval starts at $4.50. Then the next one starts at 5, and the next one starts at $5.50. So there's kind of our intervals. Now, if you're on lined paper, that's kind of nice. If you're on the iPad when you do your homework, you may want to draw these in. It's up to you. It's mainly just so that you have a point of reference for how high up your bar should go depending on the frequency. And our largest frequency is a 4, so I'm going to draw at least 4 of these lines. So our intervals go along the bottom, and our frequency goes along the left side. Now, it's very important that you label this so that you know you've taken your items to the correct heights. Now, I'm going to color code my bars, but it's kind of up to you guys. So our first frequency goes up to 4. So I'm going to draw a bar graph all the way up to 4. And then sometimes I like to fill it in just so I know that's where that one's at. So there are 4 sandwiches in that frequency. Then our next one, I'm going to do in purple here. It has 2, so we're going to go up to 2 with our bar. Our third one is at 0. Now, as a heads up, and I have to redouble check it, but sometimes on con, they'll actually place that bar somewhere in there, and as part of finishing off the con, you need to move the bar back down to 0. So if you ever end up with any intervals that are 0 on con, just make sure you drag the bar to a 0. All right, and then last but not least, our final frequency is at 4 as well. And there is our histogram. So the bars are right up next to each other. The only reason there's a gap is because one of our intervals is a 0. Again, once it's plotted, then you can ask yourself questions about it and then be able to answer. So if I said, how many sandwiches are $5 or less, you could tell me, all right, well, that's the bar, that's 4. And then there's another bar that's 2. So there's 6 sandwiches total that are $5 or less. So you can make quicker inferences about your data instead of going through this list and trying to figure out what sandwiches are less than $5 or less. So that's kind of the goal of these 2 charts. 1, organize your data, but 2, to be able to look at things, especially in a certain interval, and try